Hello everyone and welcome back to the series of digital logic design, and today we will study about combinational circuits. The logic circuit for a digital system may be combinational or sequential. A combinational circuit consists of logic gates whose output at any time are determined from only the present combination of the inputs. Or we can say that output of a combinational circuit is only dependent on present input. And the combinational circuit performs operation that can be specified logically by a set of Boolean functions. Where in contrast we have sequential circuits which employ a storage element in addition to the logic gate, and their output is a function of inputs and the state of storage element. Or we can say that the output of a sequential circuit is dependent on present input and the previous output, which is stored in the memory element. A combinational circuit consists of interconnection of the logic gate. Or we can say that a combinational circuit may consist of many logic gates which are connected together to perform some specific operations. The combinational logic gates react to the values of signals at their input and produce the value of output signal by transforming binary information from the given input data to the required output data. As the input is applied to a combinational circuit, it passes through the various logic gates and their interconnections and produce the output value according to the logic of the given circuit. Now, the block diagram of combinational circuit is shown in the figure. The n input binary variables come from an external source, and the m output variables are produced by the internal combinational logic circuit and go to an external destination. Now, each input and output variable exists physically as an analog signal whose values are interpreted to be binary signal that represents logic 1 or the logic 0. In many applications, the source and destination are storage registers. If registers are included with the combinational circuit, then the total circuit must be considered to be a sequential circuit. Or as we have defined earlier, that the output of a sequential circuit is dependent on present input and previous output, where the previous output is stored in the memory element or the register. So if you may find any combinational circuit having some memory elements involved, then this will be a sequential circuit. Now, if we have a given combinational circuit with an input variable, then we have 2 power n possible combinations of the binary inputs. And then for each possible input combination, we will have a 1 possible value for the output variable. So we can say that a combinational circuit can be specified with a truth table that lists all the possible output values for each combination of input variable. A combinational circuit can also be described by a Boolean function which represents the output variable. Or if the given combinational circuit have m output, then we will have m output Boolean function corresponding to each output variable. And then each output function is expressed in terms of n input variables. There are several combinational circuits that are employed extensively in the design of digital systems. These circuits are available in the integrated circuits and are classified as standard component. They perform specific digital function commonly needed in the design of a digital system. Here we have a few logical gates which act as an important part of the combinational circuit, whose output changes as the input varies. And these are the elements which are extensively employed in the design of digital systems and have significant use. Like we have some basic gates like AND gate, OR gate, and an inverter. The AND gate perform logical multiplication, the OR gate perform logical addition, and the inverter is used to complement the input. and all these three gates change their output as the input is changed. So these are important part of a combinational circuit.
Thanks for watching the video and stay connected for more interesting videos.